Our next topic is the subject of what is called nomenclature, which is simply a word that means a set of rules for naming. In this case, we'll be looking at the naming and writing of chemical formulas for various different types of compounds. This will be the first of 5. The simple ionic compounds are a group of compounds that are often called binary compounds because the word binary means 2. These are compounds that are made of a ratio of 2 elements. One of the elements is a metal, but not just any metal. It has to be an alkali metal or an alkali earth metal, okay, or any of the metals in the boron family. So, just to remind you, that's metals from this family, and this family. So metals from any one of these columns will appear in what are called simple ionic or binary compounds. Well, what's the other one? The other one is just any one of the nonmetals. Okay, so that's what I call binary, 2. Now, what do I mean by a ratio? Well, it's important to know that the ions, okay, the metal ion, which will be positive, a cation, and the nonmetal ion, which will be negative, an anion, are going to combine. So the overall, or that's the total charge on the compound is 0. Okay, we're going to look at some examples of how that works. So let's start with sodium. That'll be our metal, and oxygen. Okay, so take a look at your periodic tables and let's look to see what's the oxidation number for sodium, and here's oxygen, the oxidation number for oxygen. Now remember, if you've labeled your periodic table correctly, this particular column has an oxidation state. Every element in this column, when it becomes an ion, has an oxidation state of +1. It means it'll have a +1 charge. Every element in this column would be +2, and all the metals, it would be aluminum, gallium, indium, and thallium, in this column will be +3. Now let's look at our nonmetals. Nonmetals in this column would be -4. These are the ones in red. This column would be -3. This column would be -2. And this column would be -1. This is just the nonmetals. These are the ones that are shown here in this picture in red. Okay, so if we had sodium here and oxygen, we can see that the oxidation state for sodium would be +1, and the oxidation number for oxygen would be +2. Okay, let's go back to our example here. Alright, so I'm going to write Na +1. Okay, this is the sodium ion. And oxygen -2. This is the oxygen ion. Now if you look, +1 and -2 do not add up to 0. So what that means is that when these two elements combine, you don't combine in a ratio of 1 sodium to 1 oxygen. We are going to need to have 2 sodium ions for every 1 oxygen ion. That will add up to 0. So that means that the chemical formula for the compound made by sodium and oxygen, we have 2 NAs. So we write that in chemistry like this. Okay. So this means with the number that you see in chemical formulas to the right and low, it's called a subscript, tells you how many of these ions are present. In this case, there's only 1 oxygen. So we're going to write the symbol for O again, but we're not going to write a 1. In chemistry, 1s are kind of assumed. They're not absolutely necessary. Okay, so we don't write Na2O1. Also, please note that in the chemical formula, you don't see any pluses or minuses appear. All right, let's take a look at a couple of more examples. What happens if we combine magnesium and phosphorus? What does that compound look like? Well, let's jump to our periodic table real quick. Take a look at your periodic table. Okay, here's magnesium. Magnesium has an oxidation state of +2. Here's phosphorus. It has an oxidation state of -3. Okay, so let's go over here to our back here and let's write those in. Okay, Mg is +2 and P is -3. Okay, if you look at these two do not add up to 0. Well, if we try to add, we have like, this adds up to -1. Well, if we try to add another Mg, now we've got +2 and +2, that's +4, and -3, well, that's +1. Now, if we add another phosphorus, now we have -6 and +4. So you can see that, hey, if we just add that third magnesium, now we have 1, 2, 4, 6, +6, and -6. So this whole thing adds up to 0, which means that when magnesium and phosphorus make a compound, it takes 3 magnesium ions and 2 of the phosphorus ions. The compound is Mg3P2. Now, we'll do one more. We'll see if you kind of notice the pattern by now. Let's do strontium, Sr, and iodine. Strontium and iodine, Sr and I. Okay, periodic table. Sr, +2. Here's I, -1. Okay, so we have +2 and -1. Well, those don't add up to 0. You can see pretty quickly that, well, I would need 2 -1s. So that means the compound is Sr, 1 Sr, and 2 Is. So Sri2. Now, if you look very carefully, look at the numbers here. We have magnesium is +2, phosphorus is -3. And then look at the compound, and you see magnesium 3 and phosphorus 2. Look over here, we have strontium 2, and I is 1. But in the compound, there's Sr. Remember, there's a 1 here, it's just, we just don't write it. It's just assumed it's there, I2. So if you look to shortcut, rather than having to write something like this out all the time, which just takes a lot of time and a lot of space, you look at these and you write the oxidation states up here off your periodic table. When you get ready to write the formula, if you notice, you just simply switch the order of the numbers. So here it's +2, -3. In the formula, it becomes 3, 2. Just remember, do not put positive or negative symbols in the actual chemical formula. Okay, so here 2 and 1 becomes 1 to 2. Right. One last example. What happens if you put magnesium and oxygen together? Let's look at our periodic tables. Here's Mg, positive 2. Here's O, negative 2. So we have positive 2 and negative 2. Well, you look at those, you say, hey, positive 2 and negative 2 will add up to 0. That means that I just need 1 magnesium and 1 oxygen to add up to 0. So I don't need any numbers in here because it just takes 1 of each ion to add up to 0. Okay, next we're going to talk about, well, what do we call these compounds? They actually have names. First of all, when you're naming these types of compounds, the metal is always first. Okay? It's first named first, and you'll always see the symbol of the metal first in the compound. The nonmetal will be second. And in these types of compounds, you're going to change the ending on the nonmetal to IDE, ide. So for example, oxygen is not called oxygen in a compound, it's called oxide. See, here's the IDE. Fluorine would become fluoride, and sulfur would become sulfide. So for example, the compound is called, this is the metal, lithium, Li. Okay, check your periodic table. This is oxygen, so it's lithium oxide. Okay. This is Be, this is beryllium, this is a metal. Remember, you can always, remember the metals are always first, so be looking usually at the left side of the table first. Te is the nonmetal tellurium, and so it's going to be called telluride. For those of you that like to ski, there's a ski resort in a town in Colorado called Telluride. It's more pronounced Telluride, which is named because there's a lot of tellurium mines. So it was originally a mining town. Okay, one thing to notice is that it doesn't matter if there are numbers in the formula or not. Okay? They're all named exactly the same. Okay, so now it is your turn to practice some of these on your own.